helpful. We're going a little bit slow here today because we're all still dead because we all stayed up so late last night watching that championship game, which is why I canceled your homework and made it due tomorrow. But once we finish our notes today, everybody in here, including Hopeful, should be able to finish 1 through 9 on the whole sheet, and that is due tomorrow when you come to class, okay? And that will be graded, yes. So make sure that you get it done, all right? So we're dragging a little bit today, so just bear with us. It's not a very interesting lesson, but it is stuff you need to know. So here we go. All right, switching to the screen. And here we go. All right, exercise 8, because we did 7 yesterday, correct? We finished it with you?
Yep.
All right, so we're moving on to exercise 8. Exercise 8 says the pH of a sample of human blood was measured to be 7.41. And at this point, if I was on an AP exam, I would have went ahead and wrote pH above the 7.41, so I'm not confusing myself on what it is. At 25 degrees Celsius, calculate the pOH, the concentration of my hydrogen ion, and the concentration of my hydroxide ion for the sample. Okay? So the first thing it's asking me to find is what? pOH. Can I find pOH given pH?
No, you need.
Yes.
You need
14 minus 7.
Excellent. Remember this equation? pH plus pOH is equal to what? 14. So if I know my pH, how can I get my pOH? There you go. pOH is equal to 14 minus my pH, which is 7.41. So that is equal to 6.59. So that's my first thing done. Okay. Now it's asked me to find my concentration of my hydrogen ion. Okay. So do I know an equation that uses pH and concentration of hydrogen?
Yeah.
Yes. What is that equation? Excellent. pH is equal to opposite the log of my concentration of my hydrogen ion. Except normally when we use this equation, we're looking for what? pH. This time they gave me pH, and I'm looking for my concentration of hydrogen. Okay? Now this is just something you're going to need to know. When I rearrange this, trying to find my concentration of hydrogen is equal to the anti-log of my negative pH. Before you even ask, what in the world is anti-log? Don't worry about it. Just know that means you take 10 and you raise it to the negative pH, which in this case is 7.41. Okay? Don't stress about how we got there. Don't stress about what analog is. Just make sure you do that. Okay? So, if I was you, I'd have out a calculator, practicing putting it in my calculator before I get to a test, trying to do it for the first time. So my concentration of hydrogen ion is going to be equal to
3.9 times 10 to the negative
3.9 times 10 to the negative 8 molar. Now, how did I know that I only needed 2 sig figs with my 3.9? There you go. Because they gave me my pH in what? 2 decimal places, which means the rest of my answers just need to be in 2 sig figs. Okay. Everybody remember that from yesterday? We take the number of sig figs to give me how many decimal places in pH. So then if I did that backwards, I would take the number of decimal places in my pH to give me my new number of sig figs. Okay. Yes? Ty's nodding his head, so I know I did a good job explaining that one. All right. So now we've got to find my concentration of hydroxide. Did I have an equation yesterday where I used my concentration of hydrogen and my concentration of hydroxide? Excellent. Kw is equal to my concentration of hydrogen times my concentration of hydroxide. So you solve for that. You sure? All right. So what is Kw at 25 degrees Celsius? 1.00 times 10 to the negative 14th. Bella's on it today if nobody else is. All right.
You can't answer it first.
1.00 times 10 to the negative 14th plus my concentration of hydrogen I just found.
3.9 times 10 to the negative 8.
And I am looking for my concentration of hydroxide. Okay. How am I going to find it? Divide by 3.9 times 10 to the negative 8. So now my concentration of hydroxide is equal to
2.6 times 10 to the negative 7.
Should have seen.
questions about exercise 8. Anything we don't get or need to be clarified. Check us out. All right, exercise 9. Now, exercise 9, we're starting to talk about the pH of strong acids. Okay? What do I know about the pH? What do I know about strong acids? They dissociate completely, right? So, this says calculate the pH of a 0.10 molar nitric acid, HNO3. What do I know about HNO3? It's a strong acid, right? So I know that this is going to completely dissociate into H positive plus NO3 negative, right? Are you with me? Since it completely dissociates, what's my concentration of my H positive going to be? Okay, before you answer this question, let's do this example. All right, how many of us are in this room? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All right, so we have 16 pairs of ears in this room, right? We all agree with this? There's 16 pairs of ears, okay? Now, if I separate that into left ears and right ears, how many left ears are in this room? 16. How many right ears are in this room? 16.
So just be 0.1 minute.
Okay, so if I completely dissociate this HNO3 into H positive and NO3 negative, what's my concentration of this H positive?
0.1 molar.
There you go, 0.10 molar. Okay. So if I know my concentration of hydrogen, can I find my pH? Yes. What equation am I using?
The KW.
pH is equal to negative log of the concentration of H positive. It's okay, Zach.
You can use that too. You can use that. It's bearable.
So then I just fill it in. This is equal to opposite the log of 0.10. So my pH here would be 1.00. All right. B says calculate the pH of a 1.0 times 10 to the negative 10th molar solution of HCl. What do I know about HCl? It's a strong acid. Since it's a strong acid, what is it going to do? Completely dissociate into your H positive and your Cl negative. Since my concentration of my HCl is 1.0 times 10 to the negative 10th, my concentration of my H positive, if it dissociates completely, is
1.0 times 10 to the negative
1.0 times 10 to the negative 10th molar. So to find the pH, same equation. pH is equal to the opposite of the log of 1.0 times 10 to the negative 10th. Now I want everybody to have their calculator out for this.
I need a calculator. Yeah.
You need a calculator, Chief? Anybody else? Alright, so put it in your calculator. 1.0 times 10 to the negative 10th and just hit the log button. You're not doing the opposite of the log yet. Just hit the log button. What do you get?
Negative 10.
Huh? You should have gotten negative 10.
Wait, I gotta
Right.
find the logbook.
Oh, I did, yeah. I did too.
Right? So, excuse me, make sure you put a negative 10 in. You should
Oh,
have
yeah,
gotten,
we went over there.
excuse me. Thank you. You should have gotten negative 10, okay? Which is what you raised 10 to, okay? Log is based off of base 10, okay? So if I take the log of 1.0 times 10 raised to anything, my log is going to be whatever I raised it to. So when you hit the log, you should have gotten negative 10, and then I come back and take the what? Opposite of that. So my pH is equal to 10.00. Now, why is it important for me to know that? Because when I am on an AP exam and I'm on the multiple choice section, what can I not use? My calculator. So I need to be able to do something simple like that in my head. It also helps you out on multiple choice. Okay? So if they gave me, let's say 2.0 times 10 to the negative 10, is it going to be exactly 10? No, because it's not a 1.0 there. But when I look at my answer choices, I know I'm looking for a pH that would be close to what? 10. So would that be able to let me get rid of answer choices? Yes. So that's how you need to think on the AP exam. Right? They wouldn't ask you to do anything more difficult than that on a multiple choice question because you don't have a calculator. All right? Moving on to exercise 10. Exercise 10 says calculate the pH of a 5.0 times 10 to the negative 2 molar NaOH solution. NaOH is a what? Strong base. How do I know that it is a strong base? Because sodium is in what column on the periodic table? Column 1. Anything in column 1 bonded to hydroxide is a what? Strong base. Okay. So I know this is going to completely dissociate into what? Na positive and OH negative. So if this 5.0 times 10 to the negative 2 is my concentration of NaOH, it's also my concentration of what? Hydroxide. Correct? Okay. Now, if I know the concentration of hydroxide, I can easily find the what? POH. So I say POH is equal to opposite the log of 5.0 times 10 to the negative 2. So if I put that in my calculator, what do I get? You should get 1.3. How many sig figs are here? 2. So how many decimal places do I need? 2. So we're going to make that 1.30. Okay. So now that I have POH, can I find the pH?
Yes.
Absolutely. So the pH is going to be equal to 14 minus 1.30, which would give me 12.7. Yeah, yes. All right, so your homework that I gave you was based off of your exercise problems up until exercise 10. Okay, so there should be nothing on your homework that includes 8 and 9 now. You should be able to do 8 and 9. All right, and that's due tomorrow at the beginning of class. So please don't forget to do it tonight. Okay? Okay. Moving on to the next section of the notes. Calculating the pH of weak acid solutions. Now, if you notice what we did before, calculating the pH of a strong acid is really easy, right? Because whatever concentration they give me is the concentration of my hydrogen ion because it dissociates completely. What do weak acids not do? They don't dissociate completely. So therefore, when something does not dissociate completely, I have to set up our favorite thing ever, and that would be a rice table. Oh, get excited with me, okay?
But we're not even trying to. Just.
All right. So we're going to have to use a rice table. It's the same thing we did when we did it in general equilibrium in the unit before. Okay, so by the end of today, you should be so tired of rice tables. Okay, all right.
I like rice balls.
So let's look at the example. It says calculate the pH of a 1.00 times 10 to the negative fourth molar solution of acetic acid, and the Ka of the acetic acid is 1.8 times 10 to the negative fifth. Okay. All right. So it's already done for me. Yes. Okay. But we're just going to go on into this. So the first thing I do is R, which stands for the reaction. I've got to write the reaction. So acetic acid, it's HC2H3O2. So I'm going to show that that's going to dissociate completely.
No.
No, not completely. But it is going to dissociate some into H positive and into my acetate ion. Okay. Then we do I, which is the
Initial concentration.
initial concentration. So my initial concentration was 1.0 times 10 to the negative 4, which I got from the problem. Did they mention anything about my products?
No.
No. So I assume that they are 0. So we go 0, we go 0. Okay. Then we do C. C stands for the change. So in this case, my reactant should be
Negative X,
decreasing by X. My product should be
increasing.
increasing by X. Okay? So, how do I know, by the way, that it's just 1X, 1X, and 1X?
Because of the coefficients of
Because it's the coefficients. These coefficients, since there's not one, they're assumed to be what?
1.
1. So that means I'm only taking away and adding 1X. So then when we get to E, which stands for my concentrations at equilibrium, I should be at 1.0 times 10 to the negative fourth minus X, X, and X. Okay. Again, we're reviewing here. So the next thing I have to do is try to solve for X, because if I want to find the pH, the first thing I have to find is my what?
You gotta find the natural.
Concentration of my hydrogen. That's the only way I can get the pH, right? Yes. So to get concentration of hydrogen, I've got to get X. So I set up my equilibrium expression. Ka is equal to, I do my products over my reactants. My concentration of hydrogen times my concentration of acetate divided by my concentration of acetic acid. Okay. This is equal to 1.8 times 10 to the negative fifth, which is equal to x squared over 1.0 times 10 to the negative fourth minus x. Now, if this was on an AP test, I would automatically know, do they expect me to have to use the quadratic formula? No. So what would I do to this x in the denominator?
You neglected.
I neglect it. Okay. Now, if it was just x up here and not x squared, would I neglect it?
No.
No, because I could easily solve for that, right? But because it's x squared and it would make me use the quadratic, I know I can neglect that x at the bottom. Okay? So now, can I solve for x?
Yes.
Yes. What's my first step?
Multiply.
Well, let's multiply. So 1.8 times 1 is
1.8.
1.8. When I multiply exponents, I
Add
add them. Negative 5 plus a negative 4 is a
negative.
negative 9 is equal to x squared.
Now you take this.
Now I take the square root. So x is equal to, I don't know, y'all all have my calculators, so
I got 4.24 times 10 to the negative
4.24 times 10 to the negative fifth. So x gives me my concentration of what?
Hydrogen.
Hydrogen. So now that I have my concentration of my hydrogen ion, can I solve for my pH?
Just plug it back in.
Just plug it back in up here. So this is equal to the negative log of 4.24 times 10 to the negative fifth. So my pH is equal to,
I have 4.27.
4.27,
I got 4.37.
4.37.
Yes.
All Alright, how do we know that I needed 2 decimal places there? Because what's my least number of significant figures in this problem? 2. So I need 2 decimal places. We good on this? We really good on this? Okay. Good. Move on, scroll down. Exercise 11. Now I am warning you, it is about to get really tedious. Really fast. Okay? Really tedious, really fast. So just, it's easy. No. It really gets easy, I promise.
You just said it got tedious.
I know, well, tedious means like, there's a lot of like, you're writing a lot of stuff and you're going through a lot of steps, but they're not hard. Okay? So don't get bogged down because it's not hard, it's just tedious. The hypochlorite ion, OCl negative, is a strong oxidizing agent often found in household bleaches and disinfectants. It is also the active ingredient that forms when swimming pool water is treated with chlorine. In addition to its oxidizing abilities, the hypochlorite ion has a relatively high affinity for protons, meaning it is a much stronger base than Cl negative, and forms the weakly acidic hypochlorous acid, HCOl, whose Ka is equal to 3.5 times 10 to the negative 8th. Calculate the pH of a 0.100 molar aqueous solution of hypochlorous acid.
I feel like I didn't have to know any of
Okay? And you didn't have to know any of this.
So let's go ahead and write that equation.
Okay? You didn't need any of that. So don't let all the words and things bog you down. I didn't need to know any of this. All I need to know is this. So, is hypochlorous acid a strong or a weak acid? Weak. So therefore I know I'm going to have to use a what? Rice table. So the first thing we're going to do is start with our balanced reaction. So what's my balanced reaction going to be?
It's going to be HOCl goes to H positive. And HCl.
Check you out, Zach. I like it. After R comes,
them.
I. What's my initial concentration?
Gives you no, it's the 0.100.
There you go. Remember, this is my what? Ka. So this is my initial concentration. My initial concentration of my products is assumed to be 0 and 0. So when I change, I'm going to
It's going to be losing,
X and
subtracting.
there we go, losing x, adding x, adding x. So at equilibrium, I will be at
0.100 minus X, and then XX.
x. Next step is to,
On the
Products over reactants.
there you go. I've got to set up my equilibrium expression so I can do my products over reactants. So my products here, remember we always write the what first?
Always write the equation first.
The expression first. There you go. We always write the expression first. Now on the AP exam, you may have already wrote the expression in steps above, so you wouldn't need to rewrite it. But if you hadn't wrote it yet, then you would need to write your expression first. So we do products over reactants. So now I fill in. Do I know my value for Ka?
Yes.
Yes.
3.5.
It's equal to, this was x and this was x, so x times x is
X squared.
x squared over 0.100 minus x. I notice I have a square on top and x by itself on the bottom, so I'm going to
Plus
neglect x.
ooh.
So you always neglect the x, it's like by itself, it doesn't have a square, or just when it's on
Yes.
cross multiple.
So now I'm going to cross multiply. So I get 3.5 times 10 to the negative 9 is equal to x squared. So then I'm going to
Take the square root.
square root, and I get x is equal to 5.9 times 10 to the negative 5th. When I have found x, I have found my what?
You found your concentration for H on.
There you go. I found my concentration for my H positive. So now, can I find my pH like it asked me to do?
Yes.
Yes. Plug in pH is equal to opposite log of 5.9 times 10 to the negative 5th. So therefore, my pH is
4.73.
drop the mic.
What did you got?
It's not that bad. I told y'all it's not that bad. It's just long because we get tired of doing rice tables. Okay, but they're not bad. So it could be worse. It could be long and hard.
Yeah. I like it because it helps you organize. Like,
It does.
that's like very nice.
It does. Helps me keep all my information where it needs to go. All right, so before we move on to exercise 12, let's make a quick note. Okay? Sometimes they will give you a problem where they're saying we're mixing two different acids together and then they ask us for the pH. So that means I'm getting hydrogen ions from two different sources. Okay? When that happens, pick the acid with the largest Ka and use it to determine your concentration of the hydrogen ion. Okay? Everybody understand that? And of course, that means we're about to do a problem using that in exercise 12. So, exercise 12 says, and I'll warn you, like 12 and, 12 starts getting a little lengthy. So, either write smaller in your exercise box, or if you're one of those people that really likes your notes nice and neat, you might want to do it on like a separate piece of paper and stick it in your notebook with your notes. So, that's up to you. Calculate the pH of a solution that contains 1 molar HCN with a Ka of 6.2 times 10 to the negative 10th and 5 molar HNO2 with a Ka of 4.0 times 10 to the negative 4th. Also, calculate the concentration of the cyanide ion in this solution at equilibrium. Okay, now we can't do two things at once, so let's pick the first thing they ask us to do and then move from there. So the first thing they want me to do is calculate the pH. Okay? Before I can calculate pH, I have to have concentration of what?
Either hydroxide or hydrogen.
Either hydroxide or hydrogen, so in this case it's going to be hydrogen. Okay? So I look, they gave me HCN with a Ka of 6.2 times 10 to the negative 10th and 5.0 molar with a Ka of 4.0 times 10 to the negative 4th. Which one am I going to use?
HNO2.
My HNO2, okay? Because it has the larger Ka value, so that means it's going to dissociate more. So most of my hydrogen ions are going to come from HNO2. So I'm just going to ignore HCN for the time being, okay? All right, so here we go. So I'm going to start just like I always do with my rice table. So I'm going to start with my reaction. So my HNO2 is going to dissociate into H plus NO2 negative. I'll start with my initial concentration. It told me 5.00 molar, so 0 and 0 of product. Now I'm going to go through the change. I'm going to subtract X here, add X, So at equilibrium, I should be at 5.00 minus X, X, and X. So now, I've got to solve for X because I've got to get my concentration of my hydrogen ions before I can find the pH like it asked me to do. So I say, okay, well, the Ka is equal to the concentration of my hydrogen ion times the concentration of my nitrite ion divided by my HNO2. So Ka is equal to 4.0 times 10 to the negative 4, which is equal to x times x, which would give me x squared, divided by my 5.00 minus x. I know, of course, at this point I'm going to what? Neglect my x. Please make sure that you write neglect x. Don't just draw a line through it. You've got to let the people on the AP exam know that you're neglecting it on purpose, not just I'm doing this because. So now I am going to cross multiply, and I get 2.0 times 10 to the negative third is equal to x squared. I take the square root of both sides, and I get x is equal to, what'd you say? 4.5 times 10 to the negative 2. So x gives me my concentration of my hydrogen ion. So now that I have my concentration of my hydrogen ion, can I find this pH? Yes. Say pH is equal to opposite the log of 4.5 times 10 to the negative 2. How many decimal places should I have in my answer?
2.
2, because I have how many sig figs here? 2. And you should get 1.35 for your pH. Just like we did before, right?
Yes.
I'll give you a second to catch up. Have I lost anybody yet? I recommend we all go to bed early tonight, since we all stayed up late last night. Because we are all dead today.
So,
Yes.
I keep getting like 8 times 10 to the negative, when I do 4.0 times.
When you do this, did you do that to the negative 4?
Yeah, I'm divided by 5.
Multiply by 5.
That's what I do.
All right, everybody with me to this point? All right. So now let's move on to the second thing it asked me to do. Okay. The second thing it asked is find the concentration of the cyanide ion Cn negative. All right. So another rice table. Now I'm going to skip a few steps here because at this point we should all know by the time I get to the equilibrium part, I should be at 1.00 minus x, and I should be at x and x, right? Because my initial concentration of my HCN was 1.0 molar. So I know at equilibrium I'm going to subtract x. This initially was 0 and 0, so I'm at x and x. Right? I just skipped a few steps to try to save us a little trouble. Right? So if I write the Ka expression for this, say, well, Ka is equal to the concentration of my hydrogen times the concentration of my cyanide divided by HCN, right? Okay. Do I have the Ka for this?
Yes.
Yes. I'm going to erase a little bit to give me some room. Okay. I have the Ka for this. It's what?
6.2 times 10 to the negative.
Okay. Do I know my concentration of my hydrogen in this solution?
Yes.
Yes. Did we not just find it down here? Yes. So now instead of plugging in X for my hydrogen, I'm going to go ahead and plug in 4.5 times 10 to the negative 2. Are you following me there?
I was wondering how the Ka for HNO2 is bigger than HCN.
Because HNO2, it means HNO2 is a stronger acid than HCN is. So it just means that my HNO2 is going to dissociate into more hydrogens. I'm going to get more hydrogens from it. Okay.
So then you gotta.
And then I still don't know what my concentration of Cn negative is. Divided by HCN at equilibrium is 1.00 minus X, but what am I going to do? with that X. So if I cross multiply this, 1.0 times anything is just what? Itself. So that would be 6.2 times 10 to the negative 10th is equal to 4.5 times 10 to the negative 2 times my concentration of Cn negative. Let me erase so we're not getting confused. Can I solve for Cn negative?
Yes.
Yes, all I have to do is what? Divide 4.5 times 10 to the negative 2. So my concentration of Cn negative is 1.4 times 10 to the negative 8 molar. Again, tedious, yes, but doable, yes. We can do this, right? Yes. Yes. You good, Zach?
Trying to figure out, like, I wrote everything down correctly, it's all correct, I'm just trying to figure out how I just did it.
Okay, so we found x down here was equal to 4.5 times 10 to the negative 2, right?
Yeah.
And we also said, well, when we found x, that gave me my concentration of my hydrogen ion, right? Okay, so we're saying since this Ka is so little, I'm not going to get enough hydrogen from it to really affect my pH. I'm not going to get a lot of hydrogens at all. So however many hydrogens I'm getting from my HNO2 is what I'm using for my number of hydrogens everywhere. Okay. So I just plug that in there.
Oh, so it doesn't change because it's so small. Okay.
Right. Because the Ka is so small, that means it dissociates very little. So I'm saying there's not enough of it there to really affect my pH. So I just pretend like that hydrogen doesn't really exist and all of my hydrogen is coming from my HNO2.
So I did it all correctly, like I did it.
Yeah.
I was just confused on how I just did it.
Does that make more sense? Okay. And so then all I had to do was solve for Cn negative. Okay. All right. Exercise 13. More rice tables. Yay. Or not. All right. So 13 says calculate the percent dissociation of acetic acid, and the Ka for acetic acid is 1.8 times 10 to the negative 5th in each of the following solutions. Well, before we can solve for percent dissociation, we have to what? Know what it is. We don't even know what it is, so I will give it to you. All right? Percent dissociation. It is going to be something times 100. Look at how smart. Is equal to the amount that dissociated. And that's going to be in concentration, so in molarity, divided by the initial concentration. Times 100. So for A, I want to know the percent dissociation of 1 molar acetic acid. So acetic acid is what kind of acid? A weak acid. So therefore, to figure out how much dissociated, I have to use a rice table. We get so excited about those. So HC2, H3, O2 dissociates into H positive. Plus C2, H3, O2 negative. Initially, my concentration is 1.00, 0 and 0. I lose X, I add X, I add X. I'm at 1.00 minus X, I'm at X, I'm at X. Does everybody have this equation? Because I'm about to erase the percent dissociation equation. So I have room. Everybody got it? So now I set up my Ka expression. Ka is equal to the concentration of H positive times the concentration of C2H3O2 negative divided by HC2H3O2. I know my Ka, because they gave it to me, is 1.8 times 10 to the negative fifth. Is equal to x times x would give me x squared over 1.00 minus x. I know I'm immediately going to neglect x. I'm going to cross multiply. 1 times anything is just itself, so it's going to be 1.8 times 10 to the negative fifth is equal to x squared. So I'm going to square root and square root. And we get that x is equal to 4.2 times 10 to the negative third. Which is also, again, equal to my concentration of H positive, which lets me know that this is the amount that dissociated. So now that I know the amount that dissociated, can I find my percent dissociation? Yes. So we say, okay, so the percent dissociation is equal to the amount that dissociated, which was 4.2 times 10 to the negative third molar, divided by my initial concentration, which was in A, 1.00 molar, times 100. So if I put that in my calculator, I should get 0.42%. And if we were to go back and do B, we would do it the same way, except everywhere that I have a 1.0, I would replace it with 0.1. So I think we can all agree that we're okay if we just leave it there. All right, let it sink in. We got about 2 minutes left in class, so you can go ahead and start on your homework, or you can call it a day.